Hi, welcome to my video on the chain rule, which has more examples. This is more examples number 2. And again, the more examples you can see done, hopefully the better you understand. Find dy dx of each. Again, this is a composite function, and notice that we have just 2 functions. So we do, I just want to illustrate here that this is not a product. This is the cos of this value here. So it's not. Notice it's not y equals cos x sine x. That would be a product of the cos and sine. So this is, again, illustrated not a product. So that means that I'm just going to do something a bit different here. If I do d dx on the y, I could have jumped right into y prime right away, but I want to do d dx on, cos of sine x. So that's this function here. And so d dx becomes, break it down, that's dy dx as a shortcut. And this is the derivative. So it's the derivative of the main function, which is cos of sine x. There's the derivative plus the derivative of the inside. So the derivative of the inside here is the derivative of the sine x. Okay, and that gives us derivative of cos is negative sine. So the sine x is what's inside, just leave that alone. And the derivative of the inside, which is sine x, is cos x. So that becomes negative. If you want to put cos x first, and we have sine x. So one example. So what about if we have y equals x plus ln x raised to the third power? And again, we can do d dx on the y and d dx x plus ln x cubed. And the d dx on the d dx becomes d dx on the y is dy dx. And we do the derivative in terms of x on, so we do the derivative of the main function, which is this. So there's the derivative of this one. And the derivative of the inside, x plus ln x. And so let's go up right here. So dy dx. So this is a power. So that power becomes, as you can see, it's a cube. So it's 3, and it's x plus ln x squared, because you got a power. This is the function that's being composite. So treat this as an x cubed. So it's a 3, whatever this is. Well, I know what this is, but I'm saying the inside raised to the second power. Now the derivative here is a sum. So the derivative of x is 1, and the derivative of ln x is 1 over x. And so we can simplify that as, we can leave that alone, or we can leave it like that, but if we want, we can lay that as 3, and we can get x plus ln x squared, and we can add these together. So 1, the denominator is x, 1 is x over x plus 1 over x. So that's x plus 1 over x. And so we can make that 3 times x plus 1 times x plus ln x squared all over x if you want to simplify. Or we could just leave it like that there. And another one to do, again, the more we can see done, the more explanation we can understand and comprehend. And what about y equals 2 to the x to the fourth plus 5x cubed? And again, we have we do d dx to get the dy, so this becomes, again, I'll take a shortcut. The derivative here is dy dx on the y, and the derivative here is the derivative on the main one. I just write this down. Derivative on the main one, so that plus goes up a little bit higher. So there it is. That's the whole function. There's your derivative, and the derivative of the inside. The inside is x to the fourth plus 5x cubed. And the derivative here is 2. This does not change. But we have to remember that the derivative to this power becomes the same, but you have to remember how you do the ln of the base, which is 2. And now we do the derivative of this binomial. X to the fourth becomes 4x cubed. 5 times 3 is 15, x squared. And if you want to rewrite that, or you don't have to, just leave it like that. So that's a multiplication there. So it's, you can see. Again, there's two derivatives, two functions doing the composite. And here we have two functions doing the composite. The outside is sine, the inside is this function here. And so again, y prime is dy dx right away. And we get the derivative of the whole function. So it's the derivative in terms of sine. And there it is. This bracket right here, these two brackets here are here and here. So it's the derivative of all of it, which is this big bracket, times the derivative of the inside. So it's 4x squared minus cos 3x derivative. But this is I could do the derivative of this one right away, but this is a subtraction here, so I got to do the derivative of this one and the derivative of this one. So what I'm going to do is not do that derivative of the first one yet, just leave it, and I'll do all the derivatives in line. So again, I'm leaving this alone because notice that when I do the derivative here, this is a composite function inside of here. So I'll wait and leave that alone. So this is times the 4x squared prime minus, again, this is a big bracket, got to do this, with cos 3x prime. And you say, what did you do? Well, I got to go again, because dy dx equals sine. You never know how your functions are going to be, what order they're going to be, and how they're going to be. But you just got to be careful. So again, I'm not doing this yet because I got to do this. This is a composite function. Cos of 3x is a composite function. So 4x squared derivative, and derivative here is the derivative of cos of 3x times the inside. So that's the derivative of cos, and 3x is the inside function. So it's the derivative of the cos of 3x and the derivative of 3x times. There's the big multiplication. Now I'm ready to do the derivative. Derivative of cos, sine is cos, so it's the cos of this. Okay. Now the derivative of 4x squared is 8x minus the derivative of cos 3x is negative sine 3x, and the derivative of 3x is 3. So there's the big bracket, making sure. So this is cos 4x squared cos 3x times, and this is a subtraction, but this is multiplication, so this is a positive 3 sine 3x. There's the final answer. dy dx, dy dx. And again, this time I put a composite function within a composite function. So just be careful. You never know what you're going to get. And I made up one different. Do dy. Notice I have a division of two polynomials there. So we have, again, it's two polynomials. This is x cubed, and then we have this one here. So the f of x is x cubed. The g of x is this rational expression here. So dy dx, notice this is a division, so this is the f and this is the g. So when you do the derivative of this inside, you're going to do f prime g minus f g prime all over g squared when we get around to doing the derivative of the inside. So here we go. So all of it is here 2x plus 3 all over 4x minus 1 cubed. So there's the derivative of, we're doing the derivative of this power here. And now we're going to do the derivative of the inside. So there it is. So derivative here is 3, 2x plus 3, 4x minus 1, and that's a square. Power of 3 goes to the front. 3 times 1 is 3, and this decreased by 1. Now we got the derivative of this division. This is what I'm talking about, is this right here. So what we have is, I'll do this and stretch it out. So we have 2x plus 3 derivative times 4x minus 1, subtract 2x plus 3 and 4x minus 1 derivative all over 4x minus 1 squared. Again, I'm following this pattern. F is 2x plus 3, g is 4x minus 1. F, g, and this is g squared. So we're following this pattern. So simplify that, and we have 3, and we have, this is already simplified, in that the derivative is already done. So let's simplify this inside here. Now I could have done this in this step here, but I wanted to show you this pattern. And here we go. Derivative of 2x plus 3 is a 2 minus 2x plus 3. Derivative of 4x minus 1 is 4. Note, derivative of a linear is 4. Derivative of constant is 0. Again, derivative of this linear 2x is 2. Derivative of constant is 0. And this is all over 4x minus 1 squared. And we keep going. We have to simplify 2x plus 3, 4x minus 1. Just keep writing this down. So we simplify the inside of this. So that gives us 8x minus 2. That's a negative 4 time here. So it's a negative 8x minus 12 all over 4x minus 1 squared. And we keep working. Just take our time. 2x plus 3, 4x minus 1 squared. And we simplify here. Notice we did the multiplication, and I put the 4 here and multiply 4 by this. So now we're going to add. They cancel out. That gives us a negative 14 over 4x minus 1 squared. And when we multiply that, we have 3 times negative 14 is, 3 times negative 14 is negative 42. And this gives us 2x plus 3 squared. Notice this is a square here and this is a square here. So that becomes 4x minus 1 to the 4th. Again, just to remind you here, this is 3, 2x plus 3 squared all over 4x minus 1 squared. There it is there. So 2x plus 3 squared is right here. X plus 1 squared is here. So that one, which is right here, times this one, gives you, you're multiplying 2 together, so you add, you get a 4th. And again, little extra problem to help you think. A little bit of algebra. Practicing the algebra is excellent. And now I have an extra one here. Find dy dx in factored form on this function. Again, we have an f. We have two functions, f and g, so that's a product. This is f, and this is g. So this product, f times g derivative, is derivative of f times g plus f times the derivative of g. So we're doing dy dx, which is the same as y prime. Derivative here is the derivative of f, so we have 3x to the 2 derivative and sine 8x plus e to the x over 2 times the sine of 8x derivative. Okay, this is a product following this rule. So it's derivative of f times g, and it's f times the derivative of g. There it is. And what does that give us? Well, e to the x, e to the x, e to the x over 2 is e to the x over 2. But the derivative of this is derivative of that times x over 2 derivative. And that's e to the x over 2. And the derivative here is the derivative of sine 8x and the derivative of 8x. So notice we have a composite function right here, and we have a constant function here. So we have to go outside, which is this, which is all of it times the inside, and this is all of it times the inside, 8x. And we simplify that. Derivative of e to the x over 2 is the same. Derivative of x over 2 is a half x, so it just becomes a half. The sine 8x. E to the x over 2. Derivative of sine x is cos of 8x. Keep the same angle. Derivative of sine is cos. Derivative of 8x is 8. And we want to simplify that, so we have a half e x over 2 sine 8x. I'm putting the monomials in front, so that's 8 e to the x over 2 cos 8x. And I have a half and 8, so the GCF is a half, so I take out a half, and e to the x is in both parts. So when I take that out by factoring, a half divided by half is 1, so I get sine 8x. 8 divided by half is 16. Half of 16 is 8. E to the x is already there, and we got cos 8x. So that's the derivative in factored form. I just wanted to, again, do a different problem with a product, and we have two separate composite functions in here, two chain rules to do on each of these functions. Go to the problem. Helps you hopefully work through and understand. And again, like all my videos, if you like my video, click the like button, click the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained, which is just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.